When we analyze reactions in order to draw our curved arrows to show electron movement, you need to take note of the bonds that are being made and the bonds that are being broken. So I'm going to look at this first step of number 1, and these are my products here that I'm just underneath where I highlighted. And what I have is I have a new bond being made here to this oxygen bonding with this hydrogen. So it's this oxygen bonding to this hydrogen. I need to make a new bond. Now, when we draw our arrows, we draw our arrows that start with our nucleophile. So our nucleophile from the first module, we reviewed it again in module 2. The nucleophile is going to be a lone pair of electrons or a pi bond. In this case, the pi bond stays put in our product. So I'm not going to touch the pi bond. The nucleophile is going to be the pair of electrons from the oxygen. And I start my arrow there, and I need to land my arrow on the hydrogen because that's where my new bond is being made. It's being made between the oxygen and the hydrogen. Now, when I come after that hydrogen, the electrons that hold the hydrogen to the bromine drop onto the bromine. That's how I make this bromide ion, and I've shown this new bond. So the first step, the mechanism, would look as I've drawn it. I'm just going to erase the yellow parts here, and I'm going to erase these lone pairs. You're welcome to leave them in if that helps you. Now for the second step, where these are my products here, I need to analyze for what new bonds have been made and what bonds have been broken. Well, I have a pi bond in my reactant that I don't have in my product. So there's a bond that is broken. I also have a new bond here between oxygen and my carbonyl carbon, or what was my carbonyl carbon. So the oxygen of water also has 2 lone pairs of electrons. The carbonyl carbon ends up being vulnerable. So that's where my new bond is being made. So that's where I make the new bond. I start at the lone pair of the oxygen and I come towards that carbon. And I do that because I see this new bond here. Now, when I do that, the electrons of this pi bond will drop onto this oxygen. And I know it does that because over here it's positive and over here there isn't a formal charge on it. So that is how we can differentiate or figure out what our mechanism steps are going to look like. It's possible that you've never seen these mechanisms before, and that's okay. If you can find the nucleophile, you can identify where the new bonds are being made and the bonds are being broken. You can draw these mechanism steps. Now here in number 2, I have a bromine attached to my ethane, and here I have an iodine attached to my ethane. Now, when we have a metal and a non-metal, we are delivering that non-metal as an anion. So we can treat this as its own nucleophile. So these are halogens. These halogens have lots of lone pairs. So the iodine is going to come after this carbon. Remember, this is a polar bond. And because this is a polar bond that shoots or that draws the electrons towards the bromine, that leaves the carbon to be partially positive. That partially positive carbon is our electrophile. So our iodine draws towards that carbon and makes a new bond. See, I have an arrow for my new bond. Now, when it does that, the electrons holding the bromine to the ethane then drop onto the bromine. So then I have one arrow for my bond being made and one arrow for my bond being broken. And those are the steps for number 2. Number 3, analyze for what bonds have been made and what bonds have been broken. So here we have a new pi bond. So that is a bond that is made. Here we have a bromine attached to a carbon. That bond is being broken, and one of these hydrogens gets broken as well. So now I need to analyze. I know that oxygen has these lone pairs. So these lone pairs, I'm going to say, are going to come after this hydrogen. And then the electrons here are going to drop between these 2 carbons to make that new pi bond. And then this bond is then going to drop onto the bromine. Now I know that bond drops onto the bromine because bromine is left out over here. So that is how we have 3 arrows because we have 2 bonds being broken and 1 bond being made. So that's 3 arrows, an arrow for every bond being made and every bond being broken. Number 4, we have a bromine bond that is broken. And we're going to do that first. We're going to take these stepwise. So first, let's break this bond. Let's put these electrons onto bromine. How do I know those electrons are going to go on bromine? Because the next step, which is the product of my first step, shows bromine as an ion, so a bromide, and it shows a cation here, a carbocation. Then in the next step, I see that I have a new bond, and that bond is to the oxygen of water. That means water is going to act as a nucleophile. We have a lone pair here, so we start our arrow there, come after that carbocation. And we have that new bond. So that is my new bond arrow. Now I have this, and I need to take one of these hydrogens off. So I should probably change that color. So I take one of these hydrogens off. And to be thorough, there's likely some solvolysis happening where the oxygen from another water molecule will come and take that hydrogen, but that's not shown in this part. So I wanted to put that in there because that would be thorough. You don't just remove the electrons and pop off a hydrogen. That's not entirely what happens, but that is what's being shown in this step. Number 5. We have a carbon-bromine bond that is being broken. And let's see, then we're going to make a pi bond here. And we'll break one of these. So I'm going to take this stepwise. First, let's break that carbon-bromine bond. That leaves us with this product. Now I need to break this bond. And I'm going to do that by coming after that hydrogen with my water. This is the solvolysis that I had mentioned in the previous question. So I'm going to come after that hydrogen. I'm actually going to come after one of these with the lone pair of oxygen. Remember, your arrows start at the electrons and they end at the electrophile, or where the new bond is going to be made. So here, my oxygen is taking the hydrogen, and I know it's not the bromine and it's the oxygen because the product in the next step is this hydronium ion. You should remember hydronium from Chem 2. Then these electrons are going to drop into a new pi bond here, and that satiates this charge. Here we have our oxygen that comes after this hydrogen, makes this protonated alcohol. Then we have a protonated alcohol, and we're going to make a carbocation, and we're going to do that by breaking the bond between the carbon and the water molecule. Water tends to be a decent leaving group because it's stable. For number 3, analyzing that we're going to have a new pi bond being made, that means one of these hydrogens must leave. So the water is going to remove a hydrogen, and we will drop a new pi bond in there in order to satiate that positive charge. That also makes the hydronium ion, which is also the other product. In number 4, we're going to break our carbon-bromine bond in order to make our carbocation and our bromide. In number 5, it looks like we're going to trade. We want to take our oxygen and come after, I should probably do that a little bit closer. Take our oxygen, come after that vulnerable carbon. So that carbon is electrophilic because of all of the electron density pulling the electrons away from that carbon. Then we're going to drop the electrons onto bromine, and I know that because it's over here on the product side, and that will show us the substitution reaction. Number 6, we're going to break this pi bond. So the pi bond is going to come after the D. D is for deuterium. Deuterium is heavy hydrogen. And then we're going to break the deuterium-bromine bond and make the bromide anion. Then down here, number 7, hopefully that's still in frame, we have a carbocation. So the bromine is where the electrons start and they end at that carbocation. Number 8, Number 8, we need to take these in steps. So here we're going to analyze first. The pi bond is going to be broken because I can see in this product that there is no pi bond. And there is a new carbon-carbon bond. So I need to break that pi bond and I need a new carbon-carbon bond. So I will analyze this is my negative charge and it will come after my electrophilic carbon, which then pushes the electrons onto the oxygen. So I have a carbanion. This carbon is negatively charged. That makes it a carbanion. The carbonyl carbon is electrophilic because oxygen's electronegativity is greater than that of carbon. Therefore, it draws on the electrons strongly. Now, if we use this as our reactant and here is our product, let's analyze for the differences first. We're going to be adding a hydrogen here. That looks to be the only difference. So that should make it pretty easy. We only need one arrow. The arrow starts at oxygen and ends at hydrogen. So we make that new bond. So we had 2 bonds being made, 1 bond being broken. So the pi bond was broken. We have a new carbon-carbon bond and a new oxygen-hydrogen bond. So this bond is new and this bond is new. Number 9. Number 9, this is called an epoxide ring. We'll deal with epoxides in module, I think it's 6. So this is an epoxide ring, and this is an epoxide ring opening reaction. So notice that we have a new bond here, and that bond is between this oxygen and this carbon. So that means I must take my arrow this way. So it starts at oxygen. Oxygen has those lone pairs, and it ends at that carbon. We'll get into why that carbon and not the other one at another time, but it ends at that carbon. And then we push these electrons up onto the oxygen. So we have 1 bond being made and 1 bond being broken. And that's how we go from our reactants to products in number 9. Number 10, this is a tricky one. We have a pi bond and we have a bromine and a chlorine. And the bromine and chlorine, all halogens, are electron dense. And what we'll get into later is our halogens can even have some induced or partial positive natures to them. And we'll get into that another time. But what we need to look at is the differences between our products and our reactants. So here we have a pi bond. Now this pi bond is going to come up and after the bromine. That's going to make a new carbon-bromine bond. The bromine and chlorine then pull apart. So I have my chloride ion and I have a new carbon-bromine bond. That's how I can show that. Now using this middle as the reactant, looking at my products, now I have chlorine over here. So what's going to happen is the electrons start at chlorine and come after that carbocation. So I have a pi bond being broken here. I have the bromine-chlorine bond being broken. I have the bromine-carbon bond being made and the chlorine-carbon bond being made. Now, number 11, we have this bond being broken. It looks like we are also going to break a carbon-hydrogen bond. We're going to end up making that new pi bond. So let's have a look here. We might get some clues with our other products. So it looks like the nitrogen is going to come after a hydrogen. There's this new nitrogen-hydrogen bond. So I'm going to start there. Nitrogen does have a lone pair. So it's going to come after that hydrogen. When it does, the electrons between the carbon and the hydrogen have to go somewhere. So they're going to drop down between the 2 carbons and make that new pi bond. When it does that, that's going to kick the bromine off of that carbon, because remember, carbon only ever wants to make 4 bonds. So we have 1, 2, 3. We have 2 bonds being broken. We have 2 bonds being made. This bond is made as well. So that is how number 11 would work.